Hey everyone, in this video we will understand what are the different factors that should be considered while someone is analyzing the algorithms, and we will understand what is the motivation behind those factors and why they are actually really important to be understood. Okay, so this video will give you a motivation to understand those factors. Okay, so if you have not subscribed the channel, please subscribe the channel and press the bell icon for further notification of the similar videos. So let's start. So in the previous video we discussed that if we are given a problem, then we write the algorithm or the approach for this problem. Okay, and after that we write the program. Okay, so this is simply a naive approach. Okay, if we do not analyze the algorithm, then we can simply write the algorithm, whatever comes into our mind, and we write the program. Okay, then we understood that it is necessary to analyze the algorithm. So after seeing the problem, we should write the algorithm and then we should analyze the algorithms. Okay, and then we can write the program. Okay, so what is actually analysis of algorithm? So analysis of algorithm is actually a method to find the complexity of the algorithm, or you can say to find whether our algorithm is efficient or not. Okay, and we should consider some of the factors like time, okay, storage, and the other resources that are needed to execute the program. Okay, so we are going to understand in this video that how these factors, okay, or the other factors are really important. Okay, so hold on and I will tell you that what are the actually different factors, okay, that we should consider. Okay, so let's say you are given a problem and the question is you are given a sorted array and you have to check whether a particular element entered by user is present in this array or not. Okay, let's say we have to search the element 30 in this array and 30 is present here. Okay, so the question is write a algorithm, okay, or give a approach which can help to find a particular element in a given number of array or the data. Okay, so I hope you know what is the answer. So the name, or the you can say the simpler approach, is linear search. That is, we can just linearly search our element one by one with all the other elements in the array. That means we'll compare 30 with the first element. Okay, then we'll compare 30 with the next element, then we will compare with the next element, and so on till we find our element in the array. Okay, or let's say if we have to search 300, then we will keep on comparing with every element R300. Okay, and we will not be able to find R300, then we will say our element is not present. Okay, so we are comparing one by one with each of the element. Okay, that is in a linear manner. Okay, so you know that actually if we have to find this element, okay, 32, then how many number of comparisons we will do in linear search? So basically these are total 10 elements. So basically we'll first compare with this, then this, then this. So 1 2 3, then 4 5 6 7 8 9 10. So total 10 comparisons will be there, right? And if we have to search 30, then there will be total 9 comparisons. Okay, so the question is, it is okay for a smaller number of elements. If they are like 10 100 or you can say 1000 elements, then it is okay. But let's say if we are having very large number of integers or the data in this array, then what will happen? For example, if the array size is 10 to the power 9 and 10 to the power 9 is 1 billion, that means we have 1 billion numbers in our array and we have to search a particular element. Let's say we have this array and we have total 10 power 9 elements and we have to search this 700. Okay, so how many number of comparisons will be there? So you can say we have total 10 power 9 minus 1. These many number of comparisons we have to do in linear search to search this element, right? So this is nearly equal to 1 billion comparisons. Okay, so that means after 1 billion steps I will be able to know whether my element is present in the array or not. And let's say if one comparison takes 1 unit of time, then 10 to the power 9 comparisons will take how much time? It will take 10 to the power 9 unit of time. Okay, and let's say 1 unit is equal to 1 second. That means 10 power 9 unit will take 10 to the power 9 second. Okay, and if you see that what is 10 power 9 second, if you observe carefully, then you will say that it will go on years. Okay, that means your algorithm will be searching the element and it will be able to know whether your element is present in the array or not in many years. Okay, I'll tell you in the later section of this video that how big is this number. Okay, so this is nearly equal to, you can say, 31 years. So after 31 years, you will be able to know whether your element is present in the array or not. So you want to know, is there any good algorithm which can take lesser time, okay, than this linear search for a large input? So you will say, yes, there is one algorithm, that is binary search. So I hope some of you have heard about this binary search algorithm. Okay, I will tell you in the later video that how this algorithm actually works. Basically, this algorithm takes lesser number of steps to give you the output. Basically, linear search takes n steps, okay, to tell you whether your element is present in the array or not. But binary search takes log n steps, where n is the size of this array. Okay, so let's say if we have 10 to the power 9 elements, okay, that is n equal to 10 power 9, then this algorithm will take log 10 power 9 steps. Okay, after these many comparisons, you will be able to know whether your element is present in the array or not. So if base is 10, then this will come as 9 steps. Okay, if one step take 1 unit of time, so this will take 9 unit, or you can say 1 unit is equal to 1 second. So this algorithm will take 9 seconds to tell whether a particular element is present in the array or not. So if you compare 9 with this 10 power 9 second, that is 31 years, this 9 second is very less. So this binary search algorithm is better. Okay, and here we have a sorted array. So on sorted array, binary search actually works. Okay, so now let's take another example. Let's say Amit is a software developer and his manager has given his some task to perform. Okay, and his task is to code a solution for a problem. Okay, so he first wrote the algorithm and then he is coding in any of the programming language. Okay, so he deployed his solution into the server, which is having 100 GB capacity. Okay, so he deployed his code at 6 a.m. in the server and everything was running fine. Okay, now after some time, his colleagues also tried to deploy their code into this server. Okay, so again, everything was running fine. They were able to deploy their code. Okay, their code was also being loaded here, and the code it was in the process of being tested. Okay, so Amit code and their colleague code, both codes are actually working here. Okay, they are actually running here. Okay, now something happened at 3 p.m. What happened? Some of the people or some of the colleagues of Amit, they were not able to deploy their code into the server. Why? Because there came a problem of out of memory. That means server is having very less memory. Okay, so they cannot deploy their code. They cannot load their code into the server. So Amit manager called him and he scolded him very badly that what code have you written? Other people's code are not being deployed in the server. Okay, your code is so bad. What have you done? So now Amit goes to his desk and he's like again and again thinking. Okay, so he's thinking like, why can't the other people wait? Okay, my code is running on the server, so other people can wait. Or why can't the manager or the server administrator add the new servers? Okay, if this server is full, they should add new server. The Amit code was taking a lot of time to produce the output actually. Okay, and the Amit code was taking a lot of space, that is memory space. Okay, in the process of generation of the output. Okay, so this was also very high, this was also very high, due to which the other people were not able to load their code here. Now the answer is, why can't the other people wait? The answer is, time is actually money. Okay, if the other people are like waiting for your application to complete and your application has been written in so much complex manner that it is taking a lot of time, so other people will wait and the revenue of the company will go down. Okay, because less number of tasks will be completed and your code is as taking a lot of space, so other people will not be able to deploy their code, right? So again, the lesser number of tasks will be completed in the company, so revenue of the company will go down. So for the company, time and the memory space, they are actually money. But the question of Amit is also genuine, that can't we add a lot of main memory, or can't we make our hardware fast? Okay, so actually if we have infinite main memory and our CPU is very fast in the server, okay, then it is okay. Our CPU will do a lot of computation in very less time. Okay, and if we have infinite main memory, infinite space, then other people will be able to load their application in the another main memory or another server. Okay, because there will be a lot of space. But then the question is, in the 21st century, why the companies like Amazon, Google, they are taking the DSA interviews and they are asking the efficient approach in the coding interviews? If this is true, then there will be no coding interview actually. Or if there are a coding interview, then the interviewer will not ask the efficient approach. They can say, okay, if you know any programming language, that is okay. You write any code. Okay, if it takes a lot of time also, then also our CPU will be able to accommodate your solution, right? But as you know, in the 21st century, we are living in a time where we have a lot of high speed processors. That is, the frequency of the CPU is very fast. We have moved from Pentium, Core i3, Core i5, right? So our CPU should be very fast. But the answer is, the hardware people, they are doing their work. Okay, they are making the hardware fast. Okay, they are making the CPU fast. But CPU can be made fast to a particular extent. Okay, after some time, the heating problem comes, and after that, they cannot make a particular chip a fast beyond a particular limit. The same goes for main memory. Main memory is become cheaper and cheaper, but if your software is taking a lot of time to produce the answer, okay, and it is taking a lot of, you can say, space of the main memory, then till how much time your company is going to add new main memory or new servers? Okay, so basically, hardware engineers, they are doing their work. They are making the hardware fast. But as a software engineers, at least we should do our work. We should make our algorithm better. We should make our algorithm which will take less amount of time to produce the result and which takes very, very less space, okay, to produce the output. So here comes two terms, time and space. Now, again, let me give you one good example where you will be able to understand that how a large time can be there if you have written a very bad solution for a particular problem. Okay, let's say there is a problem, okay, and the question is saying something, okay, and it is taking the value of n as the input. Okay, so this is the input. Okay, this input can be like size of the array or the number of nodes in a linked list. Okay, it can be anything. So this will be entered by the user. Okay, now Amit is one person who has given a algo, okay, to solve this problem. Okay, and the solution given by Amit, they take n square calculation steps to generate the output. That means after n square steps or after doing n square calculations, algo will be able to generate the output for this particular problem. Now there is another person, Neha. Neha can give the solution, or the algo of Neha can generate the output for this particular problem in lesser number of steps, that is n log n. Okay, so I hope you know that n square is actually greater than n log n. Now let's say we have a computer in which we have a CPU whose frequency is 1 gigahertz. Okay, so giga means 10 to the power 9. So we are assuming here 1 gigahertz is 10 to the power 9 and hertz is per second. So we are assuming that 1 gigahertz is 10 to the power 9 calculation steps per second. That means this computer can perform 10 to the power 9 calculations in 1 second. Okay, so the question is, what will be the time taken to generate the output, okay, by algo 1 and algo 2 if the value of the n is 10 to the power 9. Okay, and we have to assume one calculation step takes 1 second. Okay, so we have to give the answer in second. Okay, that how many second, or let's say how many hours it will take to generate the output for the algo 1 and for the algo 2. So let's see. As it is given, the frequency is 1 gigahertz. That means the CPU can do 10 to the power 9 calculation steps in 1 second, right? That means one calculation can be done in 1 upon 10 to the power 9 second. Okay, now let's calculate the time taken by algo 1. Okay, if we make the program of the algo 1 and we run the program, okay, in the computer. Okay, so how much time it will take to generate the output by algo 1? So basically, if we find that, let's say, x number of calculation steps are being done by algo 1, then we can easily find then how much time will be taken by those x calculation steps, okay, on this computer. So here we are given that there are actually n square calculation steps being done by your algo 1 or this approach. Okay, so n square means n is 10 power 9. So 10 power 9 whole square will be 10 power 18 steps. Okay, so that means 10 power 18 calculation steps, they will be done in how many time? 1 upon 10 power 9 into 10 power 18, and this will come as 10 power 9. Okay, second. So 𝐿GO1 will take 10 power 9 seconds to generate the output. That means 1 billion second will be taken by 𝐿GO1. This number is actually very large. So basically, if you compute total number of seconds in 1 year, then it will be 3600 seconds, okay, into 24 hours into 365. Okay, 365 days are in 1 year. Okay, so total these many seconds are there in 1 year actually. Okay, and if you see, this 10 power 9 second is very large than this. So basically, if you want to convert this 10 power 9 second in year, then you can just divide 10 power 9 upon this, okay, this figure. Okay, this figure you write in the division. So you will get nearly 31 years. That means this 𝐿GO1 will be able to generate the solution for this problem in 31 years, right? So your manager will be very unhappy to know that you have given this solution for this problem. So this 𝐿GO is very slow. Okay, so I hope you can understood that how much slow is this algorithm. Now let's compute the time taken by algorithm 2. Okay, so again 10 power 9 calculation done in 1 second by this CPU. So 1 will be done in this. Okay, so basically how many steps are being taken by this 𝐿GO2? So these many steps. Okay, so n log n will be equal to n is 10 power 9. So we put the values and let's take the base 10. Okay, for making our calculation simpler. So here you can see this will be 10 power 9 and this log 10 is actually 1. 9 into 10 power 9 second, right? So basically, if you see, if I put here 10 power 9 calculation steps done in 1 upon 10 power 9 into this value. Okay, this will cut this and it will be only 9 seconds. That means 𝐿GO2 will be able to give the answer in just 9 seconds. Okay, so you can compare this time. This is giving me the answer in 31 years and this is giving me 9 seconds. So obviously this algorithm is very better than Amit. So I hope from this all discussion you can understand that why we are focusing so much on the time. Okay, so if you are given a bad algorithm, it can give you a time which is actually very large. So the bottom line of this all discussion is you should make the algorithms or the programs which actually takes the less time to execute on the CPU and which actually takes the less main memory space. So we have seen the example related to our time. Let's take a simple example to understand the main memory space also. Let's say you are given a simple problem where you are given an array and the array can contain the numbers from 0 to n minus 1. Okay, and say n equal to 30. So your array can contain the numbers from 0 to 29. Okay, for this example, and you have to print all the duplicate element in this array. Okay, duplicate means the element which has occurred more than once. Okay, some element may occur 2 times, some may occur 3 times. So you have to print those elements. Okay, so in this array 10, 8 and 22, they are the duplicate element. See, 10 has occurred 2 times, 22 has occurred 4 times. Okay, and same is with 8. Okay, so what can be the solution for this question? So basically here the point is not to understand the solution for this question. You can just go to the Geeks for Geeks or any of the site. You can find the solution. For the time being, the point is we have to just understand that different algorithm or the different solution approach for this problem, they can take different space also. Okay, they will take some extra space also to solve this problem. Okay, that is the main point to understand. We will take this example in the next videos and we will understand that what are the different approaches and how we can code them. Okay, but now the main point is let's understand the how extra space is being taken. So the first step or the first approach that can be for this question is we take the first number and we see whether this number is being duplicated in the array or not. Okay, we'll search. Okay, then we'll take this number and then we will search in the array. Okay, so we can take 2 loops. So for the first time 5 will come. Now here there is one mistake. 5 is also the duplicate element because 5 has occurred 2 times. Okay, so for the first time 5 will come. Okay, then 10 will also come. Okay, then 8 will also come, right? So on. Okay, let's say 22 will also come, right? So when you are here, okay, then also you will compare this with 22 with 22, okay, 22 with 5. So here you will say, okay, 22 has occurred again. So you can write 22 again, but you do not have to write duplicate elements again and again in the output. So for taking care of that duplicacy, you can take a separate array. So you have taken an extra array other than your original array. Let's say this array name is A. Now the another solution can be we can take two loops, okay, one loop and there can be another loop, okay. You can go for the 𝐷𝐿 and you can see the solution, okay, and we can take the extra array. This is the another solution that is posted on the 𝐷𝐿, okay. You can check there. The third solution is you take again two loops, okay, as we have taken here, but they are not nested, okay. One this loop, one this loop, they are not nested, okay. And we have also not taken any extra space. We have not taken any other array or the map, okay, and we can generate the output for this question. So three solutions, okay, but here extra array is taken or map is taken, here extra array or map is taken, okay, but lesser time than the solution one. Now in the third approach there is no space, okay, no extra space being taken. That means if we implement this algo in a program, okay, so in the server it will not create any extra arrays, okay, but this solution will create extra arrays and they can take up the memory space, okay. So interviewer will be happy to know this answer. So if n is 10 power 9, okay, so this is creating an array of 1 billion, extra array of 1 billion, but this is actually saving that extra space of 1 billion, right? So this is efficient algorithm in terms of space. So till now we understood that if we are given a problem, okay, we write the algorithm and we analyze the algorithm. We have to analyze based on time and the space, okay. Our algorithm should take lesser amount of time to generate the output, and while generating the output in that process they should take lesser amount of main memory space, okay, because these resources are, you can say, limited in our computer, okay. So first factor on which we should analyze our algorithm, or the factor on which we should observe the complexity or the efficiency of our algorithm, is time and the space. Now depending on the applications there can be some other factors on which we should consider or we should analyze the efficiency of our algorithm. One is network bandwidth. Suppose you are developing a protocol, okay, and the protocol is able to transfer the data from one computer to the another, right? So if you have developed a protocol which is taking a lot of bandwidth, okay, to transfer the data, then that protocol will not be good. You should develop the protocol that should be able to transfer the data from one computer to the another in lesser bandwidth, okay, that is in some particular unit of time large amount of data should be transferred, okay. Let's say in 1 hour you can transfer, let's say, 300 MB, but there is a different protocol in 1 hour that can transfer 1 GB data. So this protocol will be good because the bandwidth of this is very high, okay. That means 1 GB in 1 hour being transferred, okay. So while we are developing, let's say, network protocols, we should analyze our algorithms, okay, based on this factor also, that is network bandwidth. Now fourth factor is power. Let's say you are in a company and your task is to develop some of the algorithms, okay, for their mobiles, which should work in such a way that after consuming very less power they should run, okay. Very less power consumption should be there and your battery should remain or should work for longer period of time. So in those type of scenarios you should consider these power factors also, so that you can make better algorithm. And in some of the applications you should take care of the CPU registers used also, okay. Let's say you are developing some device drivers, okay, or again you are in the embedded company and your algorithm is taking very large number of CPU registers, okay, to perform some calculations, okay. So you should take care of these registers also, because in the hardware registers are limited and they are for some special purpose, right? So your application should not be taking a lot of registers, okay, to solve a particular problem. So you should take care of these things also. During our discussion of the algorithms, we will consider only the time and space, okay, because these are some of the important things that are common to various other applications also, whether you are in an embedded company or the other places also, okay. So we will remain focused on our time and the space. So basically we will analyze our algorithm based on the time complexity and the space complexity, okay. So this time will play a big role in finding the time complexity, and for the space calculation we will compute the space complexity of the algorithm, okay. So we will discuss this time complexity and the space complexity in the next upcoming videos. So that's all for this video. If you like this video, please like, share, comment this video and subscribe the channel and press the bell icon for further notification of the video. So see you in the next video. Till then, goodbye.